Alright, it's John here, and we are going to do Clojure Koan number 17 about macros. So let's get started. Up here at the top we have def macro hello with argument x, and it will return the function string hello and then x. Okay, so whatever comes in as x will just be returned, concatenated onto hello. Go ahead and define that. Next we have a macro called infix, and it takes a form as its argument, and it outputs a list. It will take the second element in that form and put it first. It'll take the first element from that form and put it next, and finally it'll take the nth of 2, which really means the third element from the form, and put it at the end. Alright, let's go ahead and define that. And next we have some blanks, so let's get down to our koans here. The first one says, macros are like functions created at compile time. Okay, so when we run our macro hello with the input of macros, then it will append macros to hello. Easy enough. So far it looks just like any other function. It just happens to be compiled. It called it compile time instead of a runtime. Alright, next icon has infix. So when we run our infix, remember it said do second, first, then third. So it'll be second, first, then third. So that will return, quite literally, plus, and then 9, and then 1, and then all that will be evaluated, and that comes out to be true. So we got that one right as well. Good. Okay, remember these are nothing but code transformations. Okay, so we do macro expand, which will run the macro part without doing the runtime part. Okay, so we essentially want to see what happens at compile time with this form that gets passed in. Let's see what comes out. So we do macro expand, and then notice here we're doing the literal form here and not calling it. Infix, and then 9 plus 1. So macro expansion will return the same things we had before, but in the unevaluated form here. There we go. So that macro expand of infix gives us the form plus 9, 1. Okay. Next, you can do better than that. Handcrafting for the wind. Okay, so we have infix better. Up here at the top, def macro infix better. Alright, so we're saying here that we have a quote, which quotes this whole form, and then we will unquote the next form, where it says second of the input form. Next we need the first form, and we need to unquote that so that it actually gets evaluated. And then again we are going to do the nth of the form. Take the second and return that. So it's essentially the same as above, except that instead of calling this list function, we basically just make a list directly. Okay, so let's evaluate that. Now we have our infix better. Let's go down to our koan that uses it. And now we have infix better. We're going to macro expand it, so if we did everything right, it will return the form times 10, 2. Let's see. Yep, we got that one right. Good. Next, things don't always work as you would like them to. Okay. It's going to run that same macro, but here we have a more complicated data passed into it. We have 10 plus the product of 2 and 3. So we'll just kind of walk through it. We're going to return the second of that thing, which is the plus function. The first is 10. And the third is this other expression, which is 2 times 3. 2 times 3. So this whole thing just will be treated as the third form of that, passed into that macro. So let's evaluate that. And yeah, we got that right. Okay, so finally it says, really, you don't understand recursion until you understand recursion. So it looks like we're doing recursive infix. And that's defined up here. Def macro r infix, we take a form. So we do a condition. If the form is not a sequence, then well, if it's not a sequence, we probably just want to return it. Okay. Now, if it is a sequence and it has exactly one element, then we are going to call our infix on the first form. Okay, otherwise we will define the operator to be the second form. The first argument is the first form, and the others will be what's left in this form. So we have, we call rest on the form, that gives us everything but the first. We can call rest again, which gives us everything left after that, which gives us the third through the rest of the original form. All right, and then we will do we'll put in our operator, and then we'll call infix on the first argument and then infix on the others. All right, so now we have this infix thing defined recursively. And let's go try it out. So this should be 10 plus 2 times 3 plus 4 times 5. So 20 plus 6 plus 10 equals 36. Let's check it out. There we go. Very cool. So we totally changed how math works here. Instead of having the operator at the beginning of each form, we just put it right in the middle. So that's fantastic. All right. Thanks for watching.